Okay, so this is how your house operates. If I was to take a chainsaw and cut right through the middle of it, take away one side of it, here's your house and this is how it's operating. Air is coming in through those windows that you were just mentioning, down low especially, and leaving at the top of the house. Okay, so it's going to find any gaps and cracks up there in the top of the house that it can to get that air is going to go out. So if we can get through effectively and seal those up, then that air is not going to come in down here, and we'll get into why that happens. It's the energy savings when you're looking at the envelope of the house. Where can you get your best energy savings, the best bang for your buck, basically? Air leaks. That's the one that I'm going to be looking at first. Where are those air leaks? Because they're very simple to stop air leaks and very cost effective, because the materials you're using is not a huge cost. It's more labor cost than it is material cost. And then we're going to start looking at the windows and doors, or the ceiling in the attic. That's the other one. Windows and doors are, we'll get into that a little later on, but they're a bigger cost, so we tend not to go there first. Okay, and we'll see why. So, building science, study of heat, air, and moisture flow within buildings. That's what I'm looking at. I mean, it's difficult for folks to get their head around that, what I'm actually looking at, but this is building science. Looking at the building as a combination of individual parts, integrated and dynamic system. So it's all working together. Previously in the past, we looked at individual parts of the house. Someone would come and look at the exterior shell of your home. Someone would come and look at the furnace. Someone would come and look at the ventilation. I'm looking at it all together and how it all interacts together, because if we're doing something to the outside shell of the building, we could essentially be affecting the water heater. The primary cause of ice dams. The houses need to breathe. What is the primary destroyer of buildings? What humidity levels should Wisconsin homes have in the winter? Does anyone know? 50%. 50% is too high, you'll rot your windows out. 25 to 35% is the target. Now, you want to be in that range and be where you're comfortable, personally. I know a lot of folks, if it gets too dry, just have like instant nosebleeds and such like that. And we don't want to go around feeling like we're alligators with our skin, like, you know, getting all crinkly, and so you got to be in that comfort, you know, where you're comfortable, but in that range of 25 to 35%. I just out of a house that's only 11 years old recently. They had the humidity at 45%. Now, they didn't realize they could control it. They've been living in this house 11 years. No one showed them where the control was on their humidifier. We're replacing 3 sets of windows because they're rotten. Now, these are only 11 years old, so you can rot your house pretty quickly. What I'm more concerned about is not the windows, what's happening in the walls. I can't see in the walls. I know I can see that windows are rotten, but I can't see in what's happening in the walls. So if that moisture is getting pushed into the walls, then you've got problems in the walls, okay? And then now, the older the home, the more likely that moisture will travel through and into the wall. The newer the home, the less likely, because we've got vapor retarders on the inside to help slow down that rate of moisture flow through the wall. I don't know if you have a humidifier, or anyone has a humidifier in their furnace, and it has a dial from 1 through to 7. What does that mean? It's got no relationship to the humidity in your home. I wouldn't look at that. I would just look at where that percentage is. And 25 to 35 is where you want to aim for. Now, if you want to sit right at 35 because you feel uncomfortable at 30, then have it at 35, but you'll be in that safe zone. Obviously, outside, maybe not so obviously, outside when the temperature drops dramatically like it is right now, we've been experiencing, so does your humidity in the house. Has anyone ever seen that? If you have a humidity gauge, you'll notice it will start going down. And that's when frost will appear on windows. It's because the coldest surfaces are starting to show up, like the windows especially, are starting to become very, very cold. Any moisture or any heat's going to be attracted to that spot, because it's a colder surface. So that's why we need to dial down our humidity, is because the lady whose house I was looking at, the one I mentioned was 11 years old, her humidity is at 45%, constant. Outside the temperature's dropping, she was wondering whether ice was starting to come up the windows. Okay, so we need to control that. Okay, does heat rise? Heat does not rise. Okay, hot air rises, heat goes in any direction it can. wants to go to cold, all right? So if you have a slab on grade or concrete floor, heat will go right through that concrete floor and outside. Doesn't necessarily have to go up. Hot air rises, and most of us have forced air furnaces, so we create warm air in the house, which then that tends to rise and that will lead into that warm air wanting to leave at the top of the